download directory. We see added that we saw in the previous version, but in this added it's 2009-02-06A. And if we ran this, if we took the download files off, had new download files, ran this again, we'd have a second file that said added with that date and B. And of course when the date changes, we'll just start getting over with added A again and the date. And then the downloads history file is just qualified with the date, because we say we don't need a qualifier for that. We'll just overwrite that. You know, we don't care that much about the subtleties of how this history file changed. We just want a backup. So that's the main addition, is that qualifier parameter on the getToday file name allows you to have multiple files on the same date qualified with a letter. You'll notice on the calls, looking at the code for version 12 in the over program, the calls to getToday file name, when we use downloads as the parameter, we say false. We don't want a qualifier. We'll just overwrite a backup file of this date every time. But then when we look at the call that creates the added file name, we say true. So this one is going to have a qualifier and is going to create multiple files if you run it multiple times on the same day, and each of the multiple files created will be qualified with a letter A, B, C, D, and so on. Alright, on to version 13, which is the last version. It's the final working program, although we do one enhancement that's external to the program that I call version 14. But in this, once again, it's a modification of the over program based on something that started to bother me, or two things that started to bother me the more I used the program. And the two things were, one, the parameter file was hard to read. The parameter file, if you look 12, looked like this. And the only way you know what each of these means is their order within the file. And the only way you know what the meaning of their order within the file is by looking at the code. And especially if you're giving this to someone else, they might not even have the source code. So they're going to be baffled as to what those are. So in version 12, or in version 13, if you look at the parameter file, what I did was I qualified each of the lines with a meaningful name, like history file equals. And then we have what used to be the only line in the parameter file. And then I have history directory equals. You can look at this and they can know what the meaning of the lines are. And also a side effect of doing this, the way the code is written, is these don't even have to be in this order. You can put them in any order in the file as long as you have these qualifiers with the correct name, like download type equals. You could put download type equals in the middle or at the top of the file and it would still work correctly. So that was an improvement of the parameter file to be more usable. Was one of the two problems I corrected with version 13. And the other problem I corrected involved the original bat file directory, or that's the name of the history directory in the case of this program. It's not in the other projects, of course. But if you look at these are on the same directory as the history file. Downloads.txt is a history file, and the transaction file or added is on there, and there may be multiple of these with different qualifier letters. And the downloads with the date, that's the backup file of the last time you did update of the downloads, is on the same directory, and here that's fine. But when you start running this for a month, you start getting tons of these files, and actually the history file itself seems to disappear, and these huge numbers of added files. So what I wanted to do was create two subdirectories, added and backup. And I put the backup files like downloads 2009-0206 in the backup directory, and I put the added transaction files in the added directory. So that's the second innovation. The first innovation was the improvement of the parameter file, and the second innovation was creating these subdirectories under. They're always going to be directly under the history file, and it's defined in the code that they're always going to be directly under the history file. So one thing you have to do when you create the history file directory is add these two subdirectories. I could write code to create them, but I just leave it up to the user to create them so he has the right file directory structure before he starts running the program. So to look at the code that actually does these two functions, look at the one that looks at the modified parameter files first. We still have a function called read parms, but now it's actually quite a bit shorter. But that's an illusion because it's calling another function called ParseLine, which now is doing most of the work that was in the original parameter file, aligning global variables to values of the lines. And in the new modified read parms, we have the same code of a string called nparm that's set to null, and then we instantiate a stream reader object, which is a class. Stream reader is a class, and the object name instantiated on it is parm_read. And once again, we create this by a call to the file class static function of open text, and we give it the name of the parameter file, and the parameter file is always on the same directory as the program, so we don't need to qualify it with a directory name or anything. And then we initially read in the first line with the readLine method of the stream reader function, or stream reader class. And assuming a line got read in, if a line didn't get read in, like the file doesn't exist or word end of file or something, the nparm string will be null. So this loop will never execute. But assuming we read a line in, it won't be equal to null. And now we're calling the ParseLine function with our string that we read in. And remember, looking at the new parameter files, the string now is a name that says what the nature of the line is, like history directory or whatever, and then an equal sign. So we need to go up to the ParseLine file and see what it's doing. Here's the ParseLine file. And there's a couple new things introduced here. One is a method that's a method of the string type. So we have a string actually defined in the parameter named nline, and we call a method of the string type called split, and we pass it a parameter of the equal sign. And what this is going to do is it's going to break the line up based on this character, and you can have an array of these characters. Split is a really useful function, and I'm calling what it splits it into tokens, which is sort of a traditional name in things like compiler construction. I worked for a compiler construction company for a few years, and they're always breaking things up into tokens, meaningful parts of the line. So now we want to look more at the method defined within the string class. If you have a type string, it's a class that actually has methods defined within it, and in this case it's the split method. So this gets into, once again, my way of writing programs quite a bit. And you find that if I write an over program, I hit a point like I did just now where I really want to write a subproblem test program again, but it's not in the course of developing the program. It's sort of off to the side. So I have a test directory, and within the test directory I have like different types of languages, CS for C#, and Visual Basic and ASP.NET, and different qualifying languages like that. And this is I put the entire Diana project within the C# test because there's a lot of interesting information that I might want to remind myself how it works. So I copied the whole Diana project in there. I also have Diana in its own directory, off under another file called .NET. But aside from the Diana, I put all kinds of different things like array list. I copied the array list test programs into this because 09 won't be that meaningful to me, but the name array list will. And array list sort, I show how to use the sort function within the array list. So if we go down here to a directory I have for saving these small test programs called split. When we open the split directory, you see I have the download history parms.txt, which I used for the test, actually for split 2. And the original split program that shows me how to use the split method, where I'm sort of programming myself before I program the computer. So I use this to program myself to know how to use the split function. And the split method of the string class, I've used it multiple times before, but I more or less forgot how it works. So I initially go to Google and I go something like parsing a line in C#, and I'll get a whole list of hits. And probably at the top of the list will be a Microsoft site, like MSDN, that has example code of how to use the split method. And I pretty much just cut and paste this example code and create my own .cs file and compile it and run it to see how it works. So this first split, don't need to really expand now since we have the big text, is I modified it slightly to run on the computer. I think I might have added the class split or something like that. But generally speaking, all this code was just directly cut and paste from the Microsoft site. And as you see in the case of their example program, they have an array called delimiter characters, and it's of type character. And one difference between things that are defined of type character and things that are defined of type string, as you'll notice, characters have single quote delimiters. So the first character member of the character array, named delimiter characters, is a space, and the second is a quote comma, and the third is a dot, a period, and the fourth is a colon, and the fifth is one of these special backspace characters like /n for new line, but this one is /t for tab. And then they have a string, which is the text that has a bunch of these delimiters in it. Like right here is a tab, and it won't print out /t, it'll print out a tabbed over space when you actually look at it. And here's a space, here's a colon, here's a comma, Here's another space. You can have the same delimiters multiple times in the line. And then it has does a system.console.writeLine. They could have a using system up there and just have console.writeLine, or they could have a using system.console and just have writeLine. But they spell the whole thing out, and they write out the original text, and they use this format where they're having a parameter that gets substituted for the variable. So it says original text, and it shows you the original line. And then it calls the split function of the string class. And it passes the delimiter characters as a parameter to the split function. And the text is the name of the string. So the fact that we're using this name and then dot split means what we want to work on is this. I think a lot of people that are first getting into this find this confusing, because the name before the dot split is what's being worked on, and this is really a parameter to the method that decides what the pattern is to work on it. And these are all being read into an array of strings called words, the equivalent of what I called tokens. And then he does a for each loop, which prints out this array of words. Basically what the for each says is read the current word. It has a built-in pointer that starts at the beginning of the array, and it said read the current array member into a variable called strings, or called s, that's of type string. And then it falls into the loop and it says print out the current s, and then it comes up to the top of the loop again, and then the for each says read the next element in the words array into s. You know, it knows that it read 0, now it's reading 1, then it's reading 2, and so on. It's iterating automatically through the words array, and it's kind of a simpler way of writing it. It defines a local variable, in this case named s, and that local variable is always updated with the current array member, and then the array pointers incremented, and then it prints out the s. So if we run this program, I'll go into my incredibly useful command prompt here, and do a directory. I almost knocked over my glass, if you're wondering what that whoop was about. And we see I've already compiled and I have the exes, so all I have to do is type in split. I could copy and paste this, but that's laziness above and beyond the Call of Duty, I think, for that many letters. And hit enter, and it shows you the original text, and then they get broken up based on these delimiters, and you have an array with each one of these tokens in it that got broken out of the line based on the split being executed. So since we have a keyword like history directory, and then an equal sign, and then the value of that keyword, doing a split based on the equal sign will break it into keyword value pairs, which is exactly what we want. But perhaps we're a little insecure about how to do that, so we create our own test program, in this case called split2, which is like a subproblem test program. And this is where the ParseLine was actually written. You see I even have some of the old code commented out here. And instead of using an array of characters, I just use one character. That's one thing I wasn't sure that it would work right. So that's one of the things I was testing in the subproblem test program. And then token 0, in this case, will be the keyword. And token 1 will be the value of that keyword. And I know what all the keyword names are. Of course, the values could be anything, but the keywords themselves are predefined. So I have a structure called switch. I'm not sure whether we talked about this in the past or not, but switch is basically like an if statement that can have multiple tests within it. And it starts with the line switch and what the value you want to test within the switch is. So in the case of our switch, what we want to test is token 0, which is the key word. And then you have case statements within the switch. And the case statement has possible values of what you're testing. So you do case double quote history file double quote, meaning you're looking at string values. They could be numeric values or whatever if what you're testing is an integer. And we're saying if the keyword is history file, assign the global variable named history file to the value, the second token in the string, and then do a break. If you don't do a break, every other case after this one's going to match. Sometimes you actually want to do that, but almost never. You almost always have a break statement here, so that once the switch works, you break out of the switch statement and go to the end of the switch and do whatever is after that, which in this case is just something that writes out the keyword and the keyword and the value associated with that keyword, as they've been broken up by the split statement. So the history file is pretty straightforward. But in history directory, we actually want to do two other things. And this has to do with solving the second problem I talked about, which is the directory getting jammed up with too many files. And we just want to, basically what we really want is just the directory, the downloads.txt, the history of all the downloads, so we can directly see where it is and what it is. So this not only assigns the history directory to token, which is the value of the keyword, in this case the keyword being history directory, but it also creates an added directory and a backup directory, which are always the history directory with the qualified subdirectory of, in the first case, added, and in the second case backup. So those are the two directories I said you need to pre-create on that file. You need to create the history directory, and then you need to pre-create two subdirectories for it, added and backup. And that's because this code is going to create those file names based on a single file name in the parameter file. And it's going to have these predefined subdirectory names, and these are going to be assigned in one case to a global variable named added directory, and in the second case to a global variable named backup directory. And once again we do our break because we don't want to do anything else other than handle the case where this keyword has been found in the line. And we do the same thing with download directory, which assigns a value to the global variable download directory, and download type, which assigns a value to the global variable download type based on the value, keyword value in the parameter file. So I then have another just test function called dump globals, which prints out all the values of the global variables that should have been set based on parsing this parameter file. And then the old read parms file I now call main for the purposes of this test program. And this is the modified read parms file we were looking at before that opens up the parameter file and just goes through the lines in a loop and calls our ParseLine file, which is does the split and does the switch case statement and assigns global variables based on what the tokens have been split up into when it reads the file. and it just loops through and reads all the lines and then closes the param files. And then we call our dump globals function to just print out what these global variables have been assigned to see if it worked correctly. So if we look at this subproblem test program, which I have in my split directory under my test programs, which are tremendously useful. If first thing I always do is look to see if I have it handled in my test programs. Like, I wouldn't have gone to Google and I wouldn't have gone to MSDN if I found the test program, because the test program I did in the past would probably have all the information I need in it. So for one thing, creating a directory of these test programs or sub-program test programs essentially causes you to be pretty autonomous. You just look at your own test programs, especially if you use meaningful names for them. And I might actually create multiple directories. I might not have just split. I might have switch, to show an example of the switch statement in case I forgot how the switch statement worked. If you work with multiple languages, it's really shocking what you forget because you have another language that does the same thing in an entirely different way, and you get confused as how the old language works. So you really depend on these test programs after a while if you do a lot of programming. So if I do a directory, I see the split 2, and we run that and see how it worked. And at the top we see actually within the switch statement where it says the file token, and gives the name of the file token, and then the word is, and it shows the value of the file token. So this is the name, the keyword, and this is the value that got broken up, and these are printed out within the switch, and these all look good. And then the switch itself is assigning the global variables, the switch within the ParseLine function. And here's our global variables, like the history file global variable, which is the history of the downloads. That's correct. The history directory, that's correct. And then we have our added directory, which just is the history directory qualified with the added of the subdirectory name, and that's correct. And we go through and we look at all these and they're all correct. And I go, great, I now have working debug code that I can incorporate back into my over program. And I don't have to worry about that code. I might have to worry about interface problems or integration problems when I incorporate it back in, but the code itself I know works, because I tested it by itself, and it's cool. So if we look at the origbat file, which is our directory download program file, and I actually ran a test of this program yesterday. There's not the added directory and the backup directory that we pre-created. And if I go into the added directory, it has a file named added 2009-0205A. So it's now putting that file in this subdirectory rather than the above subdirectory, which just has the downloads.txt in it now. And by the same token, pun intended, the backup directory just has the file downloads 2009-0205.txt. So it puts that in the correct directory also. So this test ran correctly when I integrated it into the over program. And the way this code looks when we integrate it into the over program is we now have to modify the get today file name yet again. originally it had no parameters, then it just had a prefix parameter, and then it had a prefix parameter and a qualifier that said, if this is true, add a qualifier to the dated name. And now we also need to add a parameter that says what the name of the save directory is, because it could be the backup save directory or it could be the added save directory. So when we call this file name with our 3 parameters, in the case of the backup files, we use backup directory passed as a parameter to it, which was defined when we parsed our parameters file, and then we use the hard-coded name downloads, and we use false because we're not going to use qualifier letters, we're just going to overwrite, and we assign that to a string named str today file name. And in the case of the added file names, we use the added directory as the first qualifier, which was also defined when we parsed our parameters with the new parameter parsing code. And then we use the added hard-coded name, and we say, yes, do use qualifier letters. So if the date A file exists, go to the date B file, and if that exists, go to the date C file. So I'm always having, if I do the same program 3 times in a day, I'll have A, B, and C, and I won't overwrite those files. And go to the added directory so we don't clutter up our main directory. So I think that's pretty much it. That's pretty much the entire program. I hope analyzed clearly so you understand how it works.